Okay, so we move on to unit circular functions, and this relates everything we've done so far. The common angles of 30, 60, 90, 30, 45, 60 degrees, coterminal angles, adding and subtracting 360 degrees around the origin, and puts it into a category called unit circles. All right, so the unit circle is a circle with a radius of 1. Okay, so if it's a unit circle, it passes through 1, 0, 0, 1, negative 1, 0, 0, negative 1, and every single radius is 1 unit. So every point between the points on the axes are less than 1, because 1 and negative 1 are the range of x coordinates, negative 1 to 1, and negative 1 to 1 is the range of y coordinates. So in x, y, and r, y over r, x over r, and y over x for sine, cosine, and tangent, r will always be 1 because the radius is always 1 in a unit circle. So when you have y over r for sine, it'll always be over 1, so it'll just be y for sine. Cosine will always be x because it's x over 1. So that kind of simplifies things that way for sine and cosine. So find sine and cosine in a unit circle. Okay, so if this is the unit circle, and this is theta, and this is the point on the outside of the circle, and there are the coordinates, sine is y over r, so the y coordinate of radical 3 over 2, r is always 1, is going to give you a sine of theta as the root of 3 over 2. For cosine, it's x over r, so the x coordinate is 1/2, r is 1, so the cosine of theta is 1/2. Okay, that's pretty simple and basic. Since sine and cosine are always over r, and in the unit circle r is always 1, like I just said, sine of theta will always be y, and cosine of theta will always be x. This relates to coterminal angles being positive or negative 360 degrees or positive or negative 2 pi around the origin, right? Multiples of 360 degrees or 2 pi in a positive direction or in a negative angle direction, right? And doing revolutions around the unit circle with the 30, 45, 60 common angles using coordinates at each point. Okay, so let's take a look at that picture. Below, the red x coordinates are always cosine. The blue y coordinates are always sine, right? Because sine is y over r and cosine is x over r. So here's a crazy looking circle with all the stuff on it. So you have degrees around the inside. Maybe we'll do this. Degrees around the inside of this circle. Right? And we have the radians around the outside of that. And then on each of those points, we have coordinates, and they're always going to be less than 1. What you see here is that in the chart, all of these values are represented by 30, 45, and 60. Right? That's sine and cosine of 34, 45, and 60. Those are all the values that you find over and over again in that chart that we created. And then on this side, the x coordinates are negative, but they're still a mirror image of what's going on over there. Down below, the y coordinates are always negative. Okay, so again, sine is y over r, so the blue coordinates are always sine because it's over 1. Cosine is x over r. The red coordinates, the x coordinates, are always cosine because cosine is x over r and r is always 1. So just in an example of how that relates to coterminal angles using that data up there. Let's start here. So the cosine of 480 degrees. Well, coterminal angles. So it's 360 plus what will give you 180? Well, 480, because 480 would end at the same place as that. So 360 plus 120. Okay, so 120 is basically the same value, right? The cosine of 120 is the same thing as the cosine of 480. So the cosine of 120, cosine is the y coordinate, so it's negative 1/2. So the cosine of 480 degrees is negative 1/2, just like the cosine of 480 degrees. All right, and then an example with radians and sine of 11 pi over 4. All right, so what revolution of 2 pi is that around the radian circle? So it's 2 pi plus what is 11 pi over 4? You need a common denominator. So 2 pi is 8 pi over 4, common denominator of 4, right? So I turn the 2 pi into over 4, plus what? Well, plus 3 pi over 4. So what are you really finding? You're finding the sine of 3 pi over 4, right? So the sine is the x coordinate. 3 pi over 4 is 135 degrees. The x coordinate of 135 degrees, it's negative root of 2 over 2. Negative root of 2 over 2. And the sine of 3 pi over 4 is the exact same thing as the sine of 11 pi over 4. Okay? So you have that, you have that. All right, that's just half of section 6. Relating those, the classwork and homework is page 833, number 1, 7, 9, 11, 21, 23, and 25.